Okay, here we go. Unit 6, Lesson 11. I'm filming this one in Tahoe because I want to get a head start. I have this new teaching strategy where we do a video at the end. So anyways, Lesson 11 is all about perpendicular lines in the plane. The first bullet point says, let's analyze slopes of perpendicular lines. So remember perpendicular lines. Here's the symbol for them. They form 90-degree angle. So two lines that form 90-degree angles. They do intersect, of course. Now, the image shows quadrilateral ABCD. So, question asks us this. Apply the transformation rule XY to negative YX to quadrilateral ABCD. What is the effect of the transformation rule? Okay. So the first thing you want to do is identify your points. So you got A, B, C, and D. Quadrilateral, of course, is a four-sided polygon. So what you need to do is you need to get the coordinates. So let's just start with A, B, C, and D. And then let's just write the XY coordinates next to each. So A, B, C, and D. So A is 0, 0. B is 5, -2. C is 6, 0, and D is 5, 2. Okay, now we need to move those based on this rule right here, this transformation rule. So we're going to say A prime, B prime, C prime, and D prime. And then we're going to figure out what the new coordinates are. So you just create these parentheses with the comma in between, and you just start chipping away at it. Now, the rule is that X and Y go to negative Y and X. Now I see the X here on the left, and I see the X here on the right. That means for every X coordinate, 0, 5, 6, and 5, those will be the new Y coordinates. And there's no change in sign, so literally we just take these 0, 5, 6, and 5 and put them in as the new Y coordinate. So you're going to say 0, 5, 6, and 5. Okay? Now, the Y's switch signs and become the X's. So if you switch the sign on 0, it's still 0, and it becomes the X as 0. If you switch the sign on -2, it becomes 2, and then it becomes the X. Again, 0, 2. You switch the sign, becomes -2, and then it becomes the X coordinate. So you got to be careful, really, really careful. Like, be careful on these. Set up your coordinates, set up your primes, and then get the new coordinates before you try to do anything. Trust me. I've seen these problems a million times. I've probably made the same mistakes you'll make. So anyway, we're going to now graph these new coordinates. So I'm going to use a red colored pencil. So we got 0, 0 right here. 2, 5. 2, 5 right here, which is B prime. In fact, I'm going to write these in black so you can see them. Okay, so there's B prime. C prime is 0, 6. So 0, 6 is C prime. And then lastly, D prime is -2, 5, which is right there. And that's going to be D prime. Okay, now we got all our coordinates. So step 1 is here. Step 2 is graph the coordinates. Connect the dots. Pretty simple stuff. So you just go A prime to B prime, B prime to C prime. Oh, here comes my dog. Where's Joey? C prime to D prime. Zoe, you want to get in this? Come here, Zoe. Come up here. Come up here. Come up here. Put your paws up here. Come here. Come here. Here she is. See if we can get her. Hi, Zoe. All right. Anyways, okay. So you got your new quadrilateral, and it's A prime. You could even put a prime here so you know it works for both points. So you graphed your coordinates, connected your dots. Okay. Now they're gonna ask you, what is the effect of the transformation rule? Well, let's just analyze this real quick. Let's look at the B's. So here's B and here's B prime. Notice that it forms a right angle right there. Let's look at the C's. There's a 90-degree angle from C, A to C prime. Let's look at the D's. D, A to D prime. That's also a 90-degree angle. Okay. Now, this looks to me like a rotation. Now, you could use patty paper. So you could use patty paper, but it's pretty easy without it. You could use the patty paper. That's always helpful. But the rotation, you got to remember 3 things. 1, 2, 3. A rotation, you need a center, right? You need a direction, and you need the degrees. So I can already tell, because the A didn't move when it became A prime, that your center, you could either say A or A prime, or you could just say 0, 0. The origin's the center. Now the direction, this thing's moving this direction, right? And that is counterclockwise. Now, you could have said clockwise. The degrees would have been different, though. But if we go counterclockwise, and you notice that, look at B prime and B, it's 90 degrees. So just go slowly. This is the answer to that second question. This is the answer to the first. And then if you want to graph it, that's always a good idea. Okay, that was 11.1. I'm going to keep this handy because it comes in handy for 11.2 right here. So we've now got to go to 11.2, which is to make a conjecture. Now remember, a conjecture is like an educated guess. Now we're going to use this table down here to make our conjecture. So first thing you got to do is complete the table with the slope of each segment from the warm-up. What they're talking about is this, is our warm-up. Okay, so AB, we got to get the slope of AB. So let's look at that. So from A to B, the rise is -2. And the run is 1, 2, 3, 4, 5. So the slope of AB is -2/5. Rise over the run. All right, now let's look at the image slope. Now the image is like the copy. An image is the copy, right? Or the second one, not the original. So now we're gonna go for AB prime. So here's AB prime, right? Got a little sun action I gotta deal with, which is fine. But anyway, let's look at the rise. So we're going from A to B. What is the rise from A prime to B prime? Well, the rise is 1, 2, 3, 4, 5. And the run is +1, 2. So 5/2. Now, product, you just multiply these. So let's just use the negative up here. So -2 times 5 is -10. And then 5 times 2 is 10, which equals -1. This is what we're doing at this table. Okay? So -1, cool. All right, now let's go to BC. We got to go to BC next. So look at BC. There's B, there's C. Now you got to do rise over run. Okay. Rise is 1, 2. Run is 1. So rise over run is just 2 over 1. Okay, which equals 2. But for now, I'm just going to leave it in fraction form because it's going to help me explain myself in a little bit. Okay, now we're going to get the image slope. That's the copy. So we got to go to B prime, C prime. So let's go to B prime, C prime, which is right here. So B prime, C prime. So the rise is 1. The run is -2. So 1 over -2. So 1 over -2, which is -1/2. Now the product of these, let's just do 2 times 1 is 2. 1 times -2 is -2. So again, the product is -1. So we're starting to see a pattern, which is important. It's a big part of geometry, is recognizing patterns. Okay, let's look at CD. So here's CD again. There's C, there's D. So the rise, 1, 2. The run is -1. So rise over the run. 1, 2 is the rise. 2 is the rise. -1 is the run. So you're going to say 2 over -1. Rise over run. Okay, now we're going to get the image slope. So that's C prime, D prime, which is right here. So let's take a look. C prime, D prime right here. So the rise is -1. The run, since we're going this direction, is also negative. So -1, -2. So -1 over -2 is the same as 1/2. -1 over -2 is the same as 1 over 2, because negative divided by a negative is a positive. All right, now we're going to find the product of this and this. Product means multiplication. So if we multiply this and this, we'll have the product of these two. So 2 times 1 is 2. -1 times 2 is -2, which equals, lo and behold, -1 once again. Okay, let's go to DA. So we're going D and A, right? Now let's think about it. Rise, D to A. The rise is -2. The run is 1, 2, 3, 4, -5. So -2 over -5. So -2 over -5. It's the same thing as 2 over 5. Now I'm pretty sure it's going to be -5 over 2 for the image based on our pattern. So -2 over 5 is the same thing as 2/5. Okay. All right, now let's look at D prime, A prime. So D prime, A prime, right here. Let's look at the rise. 1, 2, 3, 4, 5, but it's negative. So -5 is the rise. The run is a +2. So we're going to get -5 over 2, just like we had thought, based on the pattern. Let's do the product of this times this. So we're going to multiply this and this to get their product. So 2 times -5 is -10. 5 times 2 is 10. -10 divided by 10 is also -1. Okie doke. So we completed the table. It took us a while, but that's okay. We completed the table. Now, let's look at number 2. The image in the warm-up, the image, the red one, is a 90-degree rotation of the original figure. That makes sense, right? There's the original. We rotate it 90 degrees, goes to the red. Black goes to the red. So each line in the original figure is perpendicular. Remember perpendicular over here? There's the symbol for it. They form 90-degree angles. So each line in the original figure is perpendicular to the corresponding line in the image. What they're talking about is like AB. So AB compared to A prime, B prime. That's what they're saying. Use your slope calculations to make a conjecture an educated guess about the slopes of perpendicular lines? Well, let's look at this. -2/5 went to 5/2. So these flipped and the sign switched. 2/1 went to 1/-2. Again, the 2 and 1 flipped, and then we switched from positive to negative. On this one, we had 2/-1, and that went to 1/2. So again, they flipped and switched signs. 2/5 flipped and switched signs. So the slopes of perpendicular lines have, here's a keyword, negative reciprocal slopes. Now, what does negative reciprocal even mean? Well, that means you had a fraction, the numerator became the denominator, and the denominator became the numerator, and then the sign switches. That's what negative reciprocal means. Now, in layman's terms, or like, you might like describe this to your friends. You flip the top and bottom, and you change the sign. Flip the top and bottom, change the sign. If you want to remember what's the top, what's the bottom, think of Notre Dame football. Numerator, denominator. Okay, 11.3, prove it. Let's prove our conjecture about slopes of perpendicular lines for the case where the lines pass through the origin. All right, find the slope of a line passing through the point AB and the origin. Okay, so slope of a line passing through the point AB and the origin. Now, there's a formula for rise over run, and that is y2 minus y1 over x2 minus x1. The origin is 0, 0, right? So let's call this one x2, y2, and let's call this one x1, y1. Now, the 1s and 2s are just labels. Don't get confused on this. I'm going to close the blinds so I don't have a glare anymore. Okay. Give me a sec. Now I just have a big shadow. Okay, let me move this over. All right, so we got to find the slope of a line passing through the point AB and the origin. All right, so just use your formula, y2 minus y1 over x2 minus x1. So x2 is A, y2 is B, x1 is 0, y1 is 0. So now you just plug them in. y2 is B, right? Minus y1 is 0, so B minus 0. x2 is A minus x1 is 0, so B minus 0 is just B. A is just A. A minus 0 is A. Okay. Suppose the line is rotated using this transformation rule, xy to negative yx. Find the coordinates of the images of the points A, B, and the origin. All right, so you got A, comma, B, and 0, comma, 0. That's the origin, right? Origin's always 0, comma, 0. Now, this is a tough problem because they don't give you a graph. You just got to kind of figure it out. But we're just going to use this rule. xy goes to negative yx. So it's pretty simple You'll be shocked how easy it is. The x over here becomes the y. So A, the x, is going to be over here. Now the y, B, becomes the x, but they switch the sign. So this is going to be negative b. Now let's look at 0, 0. The x, 0, becomes the new y coordinate. So that's just going to be 0. The y coordinate, 0, becomes the x and switches the sign, but switch the sign on 0, it's just the same thing. So we found the coordinates of the images of the points. So we're good. Boom, boom, got them. Now, how does the original line relate to the image? Well, we found out by doing that rule over here. Look at this. Let's use, I'm just going to dash this line just so we're on the same page. So this dashed line that I just drew, A prime, B prime, ended up being perpendicular to AB, right? So how does the original line relate to the image? The original line is perpendicular to its image. That's if you do this rule right here. All right, find the slope of the image. So you now know that the slopes of perpendicular lines have negative reciprocal slopes. So let's look at the first line. We found that the rise over the run was B over A. So without doing any math, I know that the new image will be a negative reciprocal, which means since it's positive, B over A, we're going to switch the A and the B and make them negative. So the slope of the image will just be negative A over B. They want us kind of to run it, I can tell. So let's do this. Let's call this x2 comma y2, and we'll call this x1 comma y1. I'm gonna rewind the tape a little bit. So remember, slope equals rise over run. There's a formula, which is y2 minus y1 over x2 minus x1. Now let's look at this here. Y2 was A, y1 is 0, see, y2, y1. x2 is negative B, x1 is 0, so sure enough, ended up equaling negative A over B, like we had conjectured earlier. Now, compare your slopes. What did you just prove? You just proved that perpendicular lines have a negative reciprocal slope. Woo! What does negative reciprocal mean? Flip the top and bottom, change the sign. In math terms, the numerator becomes the denominator becomes the numerator, and the sign switches from negative to positive. Or in this case, the numerator becomes the denominator becomes the numerator, and we switch from positive to negative. So that's it. That's the big one. Here's the summary. They call them opposite reciprocals. I have always called them negative reciprocals, but opposite Reciprocals have a product of -1. We learned that in this example right here. So opposite reciprocals have a product of -1. So as long as perpendicular lines are not horizontal or vertical, their slopes will be opposite reciprocals and have a product of -1. All right, your homework's lesson 11 practice problems. Don't forget, I'm gonna check every day in class going forward. Videos 25 minutes, 35 seconds.